All right, guys, so this is going to be a how-to video on installing Kubernetes version 1.26. I think I'm going to do 1.26.1 because I think that was the most recent release when I first started this this lab. So it's going to be installing Kubernetes 1.26 on an Ubuntu 22.04 LTS and manually installing the latest Containerd release that has better support for Kubernetes 1.26. So we're going to have to do a lot of these manually because the Ubuntu repositories does not have the appropriate versions in them. An example would be like Ubuntu 22.04 in the repository has Containerd 1.5.9, which I think doesn't even support Kubernetes 1.24, maybe 1.23, but for the 1.26 certainly doesn't. So you'd want to install the newer version of Containerd. It also addresses an issue that I had to figure out on my own that I couldn't find any other guides that covered this particular thing, and that was which C group is used by the Containerd container engine. So anyhow, let's get started. This is going to be a quick build of the Linux server itself. So I'm going to go ahead and pull up my ESX server here, and we're going to go ahead and create a new VM. So I'm going to go to virtual machines, going to create a VM. We're going to say create new virtual machine. I'm going to call this Kate's controller. Yeah, that sounds right. Kate's control. How's that? So it's Linux, and it's at the bottom of the list here, Ubuntu 64. I'm going to put it on an SSD. In this example, I'm going to give it 8 gigs of RAM. You can do it with 4. It would work just fine if you were going to build this on your own computer. Hard disk, I want to be thin provisioned. I want it on a certain VLAN, and I already have the ISO uploaded to one of my data stores here, so we're going to go ahead and pick 22.04, and we're going to go ahead and build this bad boy. Okay, so got the VM. Let's click on it. It's powered up. Let's pull up this console. And let's start the installer. So while this installer is going, it does take a little bit of time, so I will pause the video once I get the installer going, but I just wanted to show you how I was building Ubuntu. It's really basic. I'm not doing anything custom with the Ubuntu install. I'm not installing any packages as part of the install either. It's just going to be a base server. Really nothing custom there. I am going to set a static IP address to match these two. So I'm doing this as like one is going to be the control and then a worker node. So that is just an example, right? So you can do it however you like. And to be honest with you, for this video, I don't even think I'm going to build the worker node. I'll show you what you're supposed to do for that. It's basically the same steps we're going to take for the control node minus the kubeadmin and init part. All right, so back to the Ubuntu build process. I'm not going to update the installer, just use it. We're going to do Ubuntu server not minimized. I am going to set a manual IP here. Subnet is /24. This address is going to be 93. The gateway is .1 as expected. So is my DNS server. 15. Okay, they all look good. Save that. No proxies on my network. I'm going to partition the entire disk. Oops. Dang it. Don't do what I just did. I think I just screwed it up. Nope, that looks good. I hit the reset on accident. That's not what I was trying to do. Okay, my name. Geek Head. Oh my gosh. Server's name. Kate's control. Pick a username. Geek Head. Type a password. Super secret. Never gonna tell you. Done. Install OpenSSH server because I want to be able to SSH to it as soon as the install's done. I don't care about third-party drivers. I'm not doing any of these add-ons, and now it's just going to do the config, and then it'll do, or the install rather, and then it'll do a, I said config because it says config on the screen. It'll do an update afterwards and then a reboot. So I'm going to go ahead and pause this, and I'll come back to when it's rebooting. All right, so it is done. Still recording? Yeah, perfect. So I'm going to go ahead and reboot. It's going to ask me to eject the CD. Again, if you don't have ESX at home, that's fine. You can do this on any platform that's like VMware. So VirtualBox on your computer would work just fine, assuming you have enough RAM. Again, you can have this VM only take up 4 gigs. So if you had a 16 gig laptop or something, you could run one of these nodes or maybe 2 of these just fine on your laptop using VirtualBox. So you can also spin them up in other cloud environments if you really feel like doing that, or just a whole variety of other options you could do. So once this boots up, I'm going to go ahead and then SSH to it instead, because SSH is easier. In this view here with VMware, I can't actually copy paste anything in there. So there's no easy way to put the commands in there. All right, so we're done there. So I'm going to go ahead and go over to the connection here. I believe this is it. Yes. Perfect. All right, so we are in. Actually, this is it right here. So let me just, whatever. I got it named wrong from the last time I built this lab. Okay, so I'm going to cheat a little bit. I know that dedicated Linux guys frown upon this kind of stuff, but I'm just going to go become root. So I don't have to type sudo for every command. So if you do sudo-s, you basically become root, and you're just the root user instead of elevating every command. All right. So basically, the first thing you're going to do with this cluster is you need to get DNS working between the nodes. And unless you have a DNS server, you're going to have to just add these in your host file, which honestly for a lab host file is just pretty easy. Like you can just add whatever you need in there, and you have to, obviously you'd have to do it to every node that's in your cluster, or your lab cluster rather, but that's also fine. It's pretty easy to do. So what I'm going to do is I'm just going to put both 93 for Kate's control and 94 for Kate's 2, which would be the worker node, into my host file. And you can do this just by manually editing the file. I'm using a printf command, so it's just going to take this text here, /n as a carriage return or new line, and it's going to take this and just append it to the end of hosts. So if I do a cat etc host, you'll see it down here, right? These two lines. So that's basically what that printf command just did. The other thing we want to do is we want to add some kernel modules overlay, which is a file system overlay, and then BR net filter, which is a bridging net firewall. So same kind of command, printf overlay and BR net filter into modules container dconf. You can run these mod probe commands if you want to. There's really no need to do that, because I'm going to reboot this when we're done with all these settings. But basically what the mod probe command does is it takes and immediately adds those modules to the kernel live. So you don't have to wait for a reboot. All right, so let's see here. The next thing I want to do is I want to add some options for bridging to allow network flow to go through your IP tables. Kubernetes, I think a lot of the Kubernetes network implementations require it. And then also the IP forward, which basically allows the net stack to forward traffic that's not intended for it to a different host, hence like your pods that were running in your cluster. You need that. Those settings are absolute requirement. So I'm going to go ahead and do another printf command into this etc system control daemon folder here. And this file name is, I think, irrelevant. You can pretty much name it whatever you want. But I want to show you what that looks like, just because the printf command has, like, the new lines in the middle of it, right? But this is what they would end up looking like at the end of that command. Systemctl is going to load those options I just put in there, which honestly probably don't need to do that either, because I'm going to be rebooting, so it doesn't really necessarily matter, but we'll put it in there anyways. The next line I'm going to do is I'm going to download containerd. So we're just going to download it to, it looks like I'm doing the temp folder. So you can see -p here means where do I want to put it. So I'm going to download this tar gzip file from containerd's GitHub 1616, and we're going to put it into temp. Shouldn't take too long, and then we're going to extract that. And the extract is just a tar command. We're extracting, passing a Z option passes it through gzip verbose, and we're going to extract it right into user local. And then this package here actually has the folder bin inside of it. And so when I extract this, it's going to end up, all the binaries are going to end up in user local bin. And you can see right there. Okay, so now I have the containerd binaries out there ready. The other thing that I'm going to do is I'm going to download, because containerd is going to be a service or a daemon, a Linux daemon. And so I want to download the predefined service from containerd's content as well. And I'm going to go ahead and output that right into systemd. So it'll create a service for me. If you want, I can cat that so you can see what it looks like. It's always a good idea to look at these things before you just use them. So basically it's just a service definition file. We're going to do a daemon reload, and I'm going to enable the containerd service. So daemon reload basically reloads it rescans the folder for new daemons and new options or whatever's in the service files. And then enable basically means enable that as a service that comes up every time you boot. And so now we've got containerd is going to start every time the system comes up, which is exactly what we want. All right, the next thing I'm going to download is a program called Run C. And this is part of the containerd runtime. And we're just going to go ahead and do an install for that. Installs it right into user local sbin. All right, the next command we're going to do is a CNI plugins for containerd. For containerd. This is a recommendation from containerd when I looked at the install docs from them. So we're just going to go ahead and go with it. Downloading that gzip file to the temp folder. And then we're going to go ahead and drop those into opt CNI bin. So let's make that folder first. And then we're going to go ahead and extract that gzip file into that folder. All right, so now we've got the CNI plugins. Next thing we want to do is configure containerd. So let's go ahead and make an etc containerd folder, and then we're going to run a command here that uses the containerd binary config default options to create a default configuration for containerd. This is really important because we're actually going to change an option in here that sets the C group. So that way the default C group used by Kubernetes, so kubeadmin, the default C group for it matches the default C group for containerd, because by default it does not. So let's go, and the piping to T basically just means pipe it to the screen and output it to a file. So we're going to go ahead and output that. I'm going to go ahead and edit this file. So vi containerd config toml, and then let's go ahead and page down twice. Yep, there we go. So right here you see this option that says systemd C group. I want that to be true. Hit escape, right quit. If you don't know how to use VI, basically when I went into the file here, I guess I should just show you that. When I went into the file here, you just hit I for insert. Now you can start typing. Escape gets out of edit mode. Typing colon opens the prompt, and WQ means right quit. If you want to quit without saving, it's Q bang. All right, so we've got that. I'm going to go ahead and just restart the containerd service, which I don't know if that's useful either, because reality is, again, we're rebooting in a second here. All right, the next option is, and a lot of guys just told you to do like a swap off. That doesn't really, I mean, it works for this current instance, but as soon as you reboot, you still have swaps. So the reality is what you really want to do is edit the FS tab file. Go to the bottom here, hit I for insert. I'm going to comment this swap line out and then right quit that. So now every time I reboot, I won't have swap. And I'm not going to worry about it turning it off right now, because I'm going to reboot before we do other stuff. I'm going to go just make sure that my apt-get is up to date. Perfect. I'm going to install some packages that I think are necessary, especially curl, because I'll probably end up using it at some point. Yeah, actually the next command is going to be curl. Probably do that as wget too, but we'll just go with curl. So we're going to go ahead and download the Kubernetes repos archive keyring so that you can access the repository. And then we're going to put that repository information into the sources list for apt-get. So that's what this command does. So let's go ahead and just do that. Now when we run apt-get update, we should get a bunch of stuff, because now it's going to be getting updates and packages from Kubernetes. See right there. So we've got the two, looks like two, for whatever reason. There's two, main and non-main. I don't know. But basically we have the Kubernetes repo and they're ready to install. Now what I want to do though next is I want to reboot, because I did all these settings and configuration to the Linux that I just want to make sure that those are ready to go before we continue this. So I'm going to go ahead and restart, and I'll be back when it's up. Okay, and we're back. So I'm going to go ahead and do the infamous sudo s, get myself in as root, because I don't feel like doing sudo for everything. And since now we rebooted, and let me scroll, oh shoot. I hope my ugly mug isn't like covering some of this text. That's all right. I'll have the text in the comments or in a file somewhere. All right. So we rebooted, came back in as sudo. And so now what we're going to do is we're actually going to install the kube binaries. So kubelet, kubeadmin, kubectl. Those are the three pieces that you're going to need for a Kubernetes cluster. So I'm going to go ahead and say apt-get install. And these are going to actually come straight from the repository, the Kubernetes repository that we added. You can see that right here. And I'm actually specifying a version here too, because I want to make sure it's the version I want. So I'm saying 126.1. The -00, I guess, is just part of the name that's in the repo. Why it's there, I don't know, because it's there on all of them. So you would think you could just say 126.1, but that doesn't actually exist. It's -00. All right. So the other thing you want to do though is you do want to put a hold on these packages. Because when you do system updates, you don't want it updating your CTL admin or let kubelet, because those need to be updated in a controlled fashion. You need to also update your control plane and everything, and yet that requires doing a kube admin upgrade command. So you don't want your OS updates also updating these. So I'm going to go ahead and put a mark hold on those, which means that next time you're on apt upgrade, it won't upgrade those. I just want to check real quick with a free-m is going to tell me whether or not my swap's disabled, because swap has to be disabled for Kubernetes. You can tell it is because I got 0, 0s, and 0s. So perfect. So basically what we just did right now is what you want to do on every node, including your worker nodes. And so these steps, top to bottom, is what you do on workers as well as your controllers. So every worker you add, put this all in there, and then do the join command. So because this is the control node, though, we're going to go ahead and do the kubeadmin and init command. And a couple options here. One is the node name. Just make sure that node name matches your node name, right? And it's matching mine. But if you didn't name yours Kates-control, it won't work. Make sure the Kubernetes version is the version that you just installed. And pod network CIDR. So this is the network range for the pods. It's a private network within the Kubernetes system. We're using Calico. So it's a private network. Calico's a private Kubernetes network versus an exposed Kubernetes network like AWS does with their CNI. And so basically, I have to change it from the default. The default's 192.168.0.0/16, but my personal home network is 192.168 range. And so they can't overlap because you'd have like routing issues. And so I have to change the pod network to 1010 or whatever it is. It just can't be the 192.168 range. So I'm going to go ahead and do that. Run this kube init pod CIDR network 1010/16, and it actually doesn't take a tremendous amount of time, but I am going to pause it just so you guys don't have to wait, and I'll unpause it when it's done. All right, so we're back, and the kube init command completed, and it completed successfully, which is good. I was hoping so. So now we've got, to start using your cluster, you need to run the following as a regular user, which would create the kube config file, which I'm going to go ahead and do this as a regular user, so I'm going to exit out of root here in a second. But I did want to comment that it's got this join command down here. You don't have to pay attention to that yet, because we're actually just going to run another command that creates a new token for the command to join worker nodes into your cluster. But let's go ahead and exit out of root. And I'm going to go ahead and take this here. Okay, I created a kube config in my standard user. So now if I type kubectl get nodes, it should show me my Kates control node. So this basically means that we're good. It's been up for 92 seconds. The kube API server is running because otherwise the get nodes command wouldn't have worked. And the not ready status is there because we have not installed CNI. So there's no network implementation done yet in Kubernetes. So we need to make sure we install the CNI, which in this case, we're going to do Calico. And interestingly enough, when I first did this like a week and a half ago, Calico's install process was actually different than it is now. It was like one file. You just install this one deployment, if you will, into Kubernetes, and your Calico network is done. But now it looks like, per their documentation, which is owned by CIDR now, or however you pronounce that, it's actually two different deployments. So now it's an operator, and then it's also this custom resources. Now the custom resources we actually have to edit this time because I'm using a different worker pod CIDR. So I'll just show you that really quick. So we're going to go ahead and just, oops. I blocked it here, but I didn't actually copy it. So let's go ahead and copy that. I'm going to install Calico 3.2.5 straight from their site. Perfect. I'm going to go ahead and do a wget on this one. I'm not going to install it directly because I need to modify it first. So I'm going to download it right to where I'm at. Now I'm going to go ahead and edit this. And if you go in here, you can see that I've got IP pools, Calico network. So this actually needs to match the IP range that I did my custom install, right? Because remember when I installed, I said I couldn't use 192.168. I had to use 1010. This needs to match that. So I'm going to go ahead and escape now, right quit, save this file. Now I'm going to go ahead and say kubectl apply f, which -f means file, custom resources. Now it's going to apply the rest of Calico. So now if we say kubectl get nodes, eventually that should say ready. We could also say kubectl get pods. Let's just do all namespaces just because I want to see everything. Not DTL, CTL. And you can see the Calico system is starting to come up, right? We've got some core DNS stuff pending. That pens, I think, because there's no network layer, so the DNS pieces can't come up yet. But this Calico system stuff is what's initializing. So we should see that eventually hit running state. And once it's in a running state, then your cluster is ready. Look, add in a couple more items. Sweet. Kube controllers is coming up. CSI node driver. Alrighty. Okay, so we've also got CIDR operator. This is a new one. Like the original Calico installs I didn't have this. At least it wasn't in that namespace, I can tell you that. Maybe there was an operator, but it wasn't called CIDR operator. Get pod. Okay, everything's running. So now if I say get nodes, you can see that Kate's control node is ready. So you actually have a function Kubernetes cluster at this point. I know it's just a control. I say cluster because it's really one node, right? You just have the control plane. So now what you want to do is you want, again, to run all of the commands I had shown you before up to basically this free-m line on all your workers. And now they're ready. They're ready for you to put in the join command. So let me show you what that join command looks like. On the control plane, you can say kube admin token create, print join command. This is the command right here that you want to copy paste right into one of your worker nodes as root. So run that sudo admin join. The IP address is the worker node's IP address, or excuse me, no, it's not. The IP address is the control plane IP address. That's your token, and I guess the SHA or something for cert hash. And that would literally join them. So I'm obviously not going to run it on here because this is control plane, but when you get to the workers, this is what you'll run, and they'll join in. And when you next time you run get nodes, you'll see your worker nodes displayed there. And that's basically how you get Kubernetes up and running, Ubuntu 22.04 with the latest container D. Hope that was useful for you guys. Appreciate it. See you on the next video.